Okay guys, just when you thought you were done with the quartiles, they're back! Alright, this is 12.3 box plots, and they used to be called box and whisker plots, so we call them box plots for short. And this starts on page 879. So we're going to look at the real world link, and it says that the table shows the number of touchdowns scored by each of the 16 teams in the National Football Conference in a recent year. So they showed the number of touchdowns here and scored by each of the 16 teams. So there's 16 values here. It wants us to plot the data on the line plot. So again, we're going to do our little X's on our line plot here to represent each of these amounts. You can do an X or you can do a dot, whatever is up to you. So go ahead and do that now, please. Pause the video. Alright, so that took some work. I was using dots and had to make sure they were the right size since we're going in between spots here. So it says find the median, lower extreme, upper extreme, first quartile, and third quartile of the data. Place a star in the number line for each value. So the lower extreme and the upper extreme just mean the lowest number and the highest numbers. So if we're filling in the easy stuff, we can obviously do these guys, and then for our quartiles and our median, we're going to have to get to some work here. So of course for median, they're already in order from greatest to least if you have it on the number line, or you can rewrite the numbers entirely. It's completely up to you, whatever works for you. I'm going to go ahead and I'm going to do the n+1 method to find the position. That way I don't have to do the tag you're it. So using the British guys method of finding position, I'm doing n+1 divided by 2. We have 16 values altogether. So 16 plus 1 divided by 2 will be 17 divided by 2, which is 8.5. So it's the 8.5 position. So let's see. 1, 2, 3, 4, 5, 6, 7, 8.5 will fall right here. And of course that's between 37 and 38, so we would add these two together and divide by 2, and I hope that you just know that it would be 37.5, because what's halfway between 37 and 38? 37.5. So our median is 37.5. Then I'm going to use a different color for this since I'm changing gears here. Now we're going to talk about quartiles, and of course you know that we count the amount of spaces after the median and before the median to figure out what our n+1 would be. So for this, our n+1 would be 1, 2, 3, 4, 5, 6, 7, 8. So we're going to have 8 plus 1 divided by 2, which is 9 divided by 2, which is 4.5. So we're looking for the 4.5 position. If you're trying to write down 4.5 as your first quartile, I hope that you realize that that doesn't make any sense. How is 4.5 going to be one of your quartiles when your numbers are between 24 and 54? It doesn't make any sense. So we're just looking for the 4.5 position. So that would be right here. Now that's kind of a big spread. That's going to be between 28 and 34. And so if you add 28 plus 34 together and divide by 2, you'll find that the first quartile will be 31. Okay? Now doing the same thing from the end, I'm looking for the 4.5 position from the end, and that's going to land me right here between 44 and 47. So I'm going to do for my quartile 3, 44 plus 47 and divide that by 2. And that will ultimately be 45.5. Again, if this was too confusing with it on the number line, then you can certainly write out the numbers in order from least to greatest. That's perfectly fine as well. But I find using the positions like the British guy showed us is super helpful in this kind of situation. Alright, the next thing says what percent of the team scored less than 31 touchdowns? So what percent of the team scored less than 31 touchdowns? And don't get crazy. Don't start pulling up some numbers to do math with. Let's think about what our quartiles mean. This group is 25% of the data. This group is 25% of the data. This group is 25% of the data. And this group is 25% of the data. So if I'm looking for the ones that's under 31 touchdowns, then I'm just looking for this space right here, which is 25% of the touchdowns. Then number 4 says what percent of the team scored more than 37.5%. We found that median was that 37.5%. So this information from here to here is the percent of the data that's above 37.5%. And so that's 50% of the data show that more teams scored 37.5 touchdowns. All right. So that's just a little review, really, of looking at quartiles. So we're going to move on to constructing a box plot. So a box plot, or box and whisker plot, uses a number line to show the distribution of a data set by using the median, quartiles, and extreme values. A box is drawn around the quartile values, and the whiskers extend from the quartile to the extreme data points that are not outliers. Okay, so that's interesting that they're making sure that you understand that the upper extreme isn't going to include an outlier. All right, and remember that you can figure out whether or not a number is an outlier by figuring out the IQR and then multiplying it by 1.5, adding it to the quartiles, and adding it to the quartile 3, subtracting it from quartile 1, and that gives you what your upper and lower extremes will be, and anything outside that will be your outliers. Okay, or I shouldn't say that's what your lower and upper extremes will be. That's not what they will be. That's what they could be without it becoming an outlier. Okay, so a box plot separates data into 4 parts. Even though the parts may differ in length, each contains 25% of the data. So you notice that this little space right here is 25% of the data. This big space right here, well, I shouldn't say that, sorry. Not the big space there. This big space here is 25% of the data. This space here, 25%. This space here. So notice that they're all different sizes. They're not all matching. That's not how percents work when we're talking about information, because of course it's not perfectly distributed amongst the data, okay? All right, and then the box always shows that middle 50%. Right here, from quartile 1 to quartile 3, always shows 50% of the data. So it says to draw a box plot of the car speed data. So first of all, we order the numbers from least to greatest and draw a number line that covers the range. So step 1 is putting them in order from least to greatest. Now that you've got that written out, you're going to have the lowest and highest numbers. So I know that my number line needs to represent numbers from 19 all the way up to 40. So how you want to set up your number line is completely up to you. If you want to do it by ones values, if you want to do it skip counting by twos like they did in the example, whatever works. They've showed it by fives with little tick marks in the middle, which is fine, except that it's hard kind of to make sure your dots are in the right spot whenever you're plotting all these points. So now we've got all our numbers in order from least to greatest. We're going to find the median, the extremes, and the first and third quartiles. So I'm going to go ahead and set up my own number line. So I'm going to set up mine with my spacing of 5 just like they did, but I'm just making a bigger picture so that I can see it a little more clearly. You can put your smaller tick marks in as well. That'll be completely up to you. Now we want to find the median and the extremes and the first and third quartiles so that we can plot them on this number line. We're going to mark those are the important parts. Now we already know what our low extreme is and our upper extreme is, so we can plot those right now. So I'm going to put my 19 here, and then I'm going to put my 40 is already here. So these are my points. Well, I guess I should have put my 19 below. Okay, so that's my point, and that's my point. And if it's not on my number line, I really should show that this is 19. All right, the next thing I'm going to do is find my median. Since they're already in order from least to greatest, I could just do my tag URIT, or you can do the the British Guys method of n plus 1 divided by 2. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There's 11 values plus 1 will be 12 divided by 2, which is the 6th value. So 1, 2, 3, 4, 5, 6. This is going to be your tag URIT, tag URIT, tag URIT, and 25 is the median. So I'm going to, trying to write, okay, there we go. This is my median. Then I'm going to find my quartiles. So I'm going to not include 25, this 25 that I circled. This is kind of like the block off point. 25 has been used, so if I'm looking at the numbers to make up my my quartile 1, I'm only counting 1, 2, 3, 4, 5 digits. So I'm going to do my n plus 1 divided by 2, where n is 5, and 5 plus 1 is 6, divided by 2 is 3, so it's the third position, which is 22 on this side. So we'll say that's right about here, 22, and this is my quartile 1. Then I'm going to do the same from the other side. The third from the last on the other side is 34. So I'm going to put my 34 right about here. Put my dot up here, label it quartile 3. And so I have my low, my lower extreme, my upper extreme. I've got my quartile 1 and 3, and I have my median. Now we're going to draw a box so that it includes the quartile values. So when we're drawing our beautiful box, I know you're really excited to draw the box now, we're going to put a line through our quartiles and a line through our median, and we're just going to connect them together. And then we're going to also draw a vertical line from, oh, okay, we already did that, and then we're going to extend our whiskers. So I know it seems like a lot, but it really does just become second nature. The hardest part is finding the quartiles in the median, and then you're just making a box and putting whiskers in. I mean, it's not really that big a deal. So you've got your low, your high, your quartile 1, quartile 3, and your median. And this represents the data. These are car speeds. So we're going to title our graph, or our box plot, as car speeds. So if I were to look at this information and say, okay, what does this say? What does this box plot tell you? Well, it tells me that most people, like 50% of the people, are going between 22 miles per hour and 34 miles per hour. 50% of the people are doing that. I would say that the fastest person is going 40 miles per hour and the slowest person is going 19 miles per hour. I'd say that the median average is 25. And all of that is in this box plot. Okay. All right, so common misconception is that you may think that the median always divides the box in half. However, the median may not divide the box in half because the data may be clustered toward one quartile. So if we were to do that box or the line plot like we did for the first example, and you saw where the clusters were, you'd see that there's a big cluster in the 22 to 27 range. So of course that's going to make your median kind of veer over to the left some there. So yes, I think that's a great point that the book makes, that you're not just looking at it as it's split, a box split in half, because it's not always going to be that way. My median is not splitting my box in half. So great point. All right, so we're going to draw a box plot of the data set below. Of course, you want to keep following your step-by-step directions that you have over here. They're perfect. So we're going to put them in order from least to greatest first. Then we're going to find the low and high, the lower and upper extreme, the quartiles, and the median. Then we're going to draw the box and whiskers and put a title on it. Okay? I want you to pause the video, and I really want you to try doing this on your own. There's not like a really good title put on here, so we'll just put dollars. Okay? All right, pause the video now and do this on your own. I'll come back and I'll have the work. So I've written them all out from least to greatest. That's my step 1. And now I'm going to move on to step 2, where it says I need to now figure out what my mean, median, mode, outlier, or lower and higher extremes are. Okay, or lower and upper extremes. Sorry, I'm never going to get that right. So now it's the hard part. Okay, we're going to get some work done now. So to find my median, I'm going to use the British guy's way of doing it, so I don't have to do TAGURate. You're welcome to do TAGURate. It doesn't really matter. There's 11 data values. Plus 1 divided by 2 is going to be 6. So 1, 2, 3, 4, 5. The sixth value is 20. So that's our median. Then our quartile 1, I'm going to do my n plus 1 divided by 2, and this time I'm only including this data because 20 has already been used. So I've got 1, 2, 3, 4, 5 values. Plus 1 divided by 2 will be 3. And so my third value on my left will be 17. And my quartile 3 third value from the right will be 27. And then now I just need to plot these on a line. So I'm going to make a number line. My lowest value is 15 and my highest value is 30. So those are my parameters I need to make sure I put on my number line. So I've made my number line 15 to 30, skip counting by 5s, but I know I'm going to have to put numbers on the inside here, and that's perfectly fine. So the first thing I'm going to do is put my extremes. My lower extreme and my upper extreme are my 15 and my 30. My line does not have to start with 15 and 30. As their example showed, they started with 10 and ended with whatever. So you don't have to start with 15 and end with 30. It just happened to work out that way for me, and I liked it. Now I'm going to do my median. My median was 20, so I'm going to put my median right here, and I'm going to label it with an M for median. Then I'm going to put in my quartiles, and my quartile 1 was 17, so it's kind of towards the center here, 17. And then my other quartile is 27, just on the other side here, kind of in the middle almost for 25 to 30. And again, you can put points for every single one. I'm just, being lazy. Alright, then we're going to put our lines through our 3 dots in the center and connect our box. Oops, and I forgot to label my quartiles. Hold on a second. This is quartile 1, quartile 3. Alright, then I'm going to do my whiskers. And there you go. My box plot is finished. I've got my quartiles. I can say, okay, I know that if I'm interpreting my data here, I know that my lowest amount of money was 15 and my highest amount was $30. I guess I should put money as my title here, although can't see it very well. And then most of my money, dollar amounts, landed between 17 and 27, 50% of the data did. And my median amount was $20. Alright, so though a box plot does not show individual data, you can use it to interpret data, just like I was practicing just now. It says refer to the box plot in example 1, so I just pulled the box plot back up so that we have it here. It says half of the drivers were driving faster than what speed? Half of the 11 drivers were driving faster than 25 miles per hour, because the fastest half, the top fastest half, was this section right here, even though it's not in a box. I know it's not. It's crazy, I know. But half of my data, the higher half of my data, was right here, and so it was over 25 miles per hour because that was my median. If it asked, half of the drivers were driving slower than what speed? Well, this is the second half of my information, and they were going slower than 25 because my median was 25. That's where we got the information. The next one says, what does the box plot's length tell about the data? What does the box plot's length tell about the data? Well, it tells us that the speeds, well, let's see what they say. They say the length of the left half of the box plot is short, and that means that the speeds of the slower half are concentrated, the speeds of the faster half are more spread out. Yet the larger the spread, the longer your whisker, or the larger your set of information in your box plot is, we're talking about it being more spread out. So the more clumped our data is, it means that we had a lot of them that fell into here. And the more spread out this space is, means that we had more spread out data like that. Okay? But wherever we have closer data, it means that there was more data in that concentrated area. So really key words here are concentrated and spread out, okay? Wherever the smaller is, okay, the smaller means more concentrated. And then the concentrated, and then the larger the line is, or longer, I don't know how to say that, longer or larger the box or line is, the more spread out. All right, now for B, it says what percent we're driving faster than 34 miles per hour. I want you to pause the video and look at this, and I gave the chart right here again, the box plot, for you to figure out what percent we're driving faster than 34 miles per hour. Pause the video now and figure that out.
Pause the video! Pause!
So 25% is the percent that we were driving faster than 34 miles per hour. 34 miles was our quartile 3, and so faster than that is only that very last whisker there, which is 25% of the data. The box plots, it says if length of a whisker or box is short, the values of the data in that part are concentrated. If the length of the whisker or box is long, the values of the data in that part are spread out. Weird, because I feel like I just said that and made you guys write it. All right, example number 4 says that the box plot shows the daily attendance at a fitness club. Find the median and the measures of variability. Then describe the data. We have a fitness club attendance. All right, the median is 72.5, the first quartile is 65, and the third quartile is 80. So they've given us... All right, sorry, I just had to pause for a second because I'm trying to figure out if I was missing the data values, like the individual data values, and apparently they aren't giving that to us. They're just giving us this chart. I would prefer if they were giving us this information that they would be very specific about what this number was, since it's not like it's on a line. But what we can see is that the lowest number is somewhere around 56, and that the highest number is 90, but that there is an outlier of 110. And then I would also say that the first quartile is at 65, and that the third quartile is at 80. And then in between there, we've got the median, which 72, 72 and a half, something like that would be fine. I would take it because they're not giving us any actual information to go off of. So this is just them writing it in words to describe the data. So it does say that both whiskers are approximately the same size of the data without the outlier. The spread is evenly below and above the quartiles. So this is pretty even. Now, if I had a whisker that was going all the way out to my outlier, then of course that would be, you know, obviously a big spread of information right there. But because they've identified that this 110 is an outlier, because it's so spread out from the other numbers, that we're not going to include that as part of the whisker, but we do need to identify it. So outliers. If the data set includes outliers, then the whiskers will not extend to the outliers, just to the previous data point. Outliers are represented by an asterisk on the box plot. So that's what they showed us here. We've got the little asterisk that shows that this is the outlier, but this is the next largest value, and that's what we would use as our upper extreme because the outlier isn't included in that. Now you're going to do C on your own. The number of games won in the American Football Conference in a recent year is displayed below. You find the median and the measures of variability, then describe the data. So go ahead and use this, and luckily it's going to be more straightforward for you to be able to figure out what the numbers are since they're not so spread out. Go ahead and write something very similar to what they gave us right here. You can use that as a guide if you'd like. And pause the video now. All right, so you should have written that the, the lowest amount of wins in the conference was 1, and that the highest would be 13 for each team, the highest amount that they've won. Then the median would be about 8.5 wins, and the first and third quartiles, where 50% of the data will lay in between, will be between 5.5 and 11. Will be where most of the data, or where 50% of the data would be. And then, And then, you know, I see that the information is more spread out in the first half, we'd say, of the data set, because this is a bit longer, maybe. I mean, definitely within the whisker, it's a lot longer. That the first 25% of the information is spread out, and I'd say the second 50% of the information is, you know, it is more concentrated. Now, there's some extra examples that you can do if you want to continue watching the video. Otherwise, you can stop now. I think that we have 5th period wants to give a shout out.
Yeah!
All right, so number 10 on one of the other pages that as you go through, an extra example is height and waves, and they've given us all this data here. They've given us this number line to use so that we don't have to create our own, but what we do need to do is figure out the median, the quartiles, and the lower and upper extremes. So first thing, remember step 1, you put them in order from least to greatest. So if you're doing this with me, go ahead and pause the video now and put them in order from least to greatest. All right, so step 1, I put them in order from least to greatest. Now step 2, I'm going to figure out what the median and the quartiles are. I already know that my lower and upper extremes are here, so I could go ahead and put those on already. I've got my 40 and 81. And then I'm going to find the median now. I'm going to use the British guy's way of doing it just so I can keep this clean and not have to make it dirty. All right, so I found that it's going to be in the 8th position. So 1, 2, 3, 4, 5, 6, 7, 8. The 8th position is 67. So above 67, I'm going to put in right here. And I'll just say that this is 67, this is 81. This is our median. Then now I'm going to find the quartile. So for quartile 1, I'm going to take the numbers that are to the left of 67 and count how many there are. 1, 2, 3, 4, 5, 6, 7. So n plus 1 is going to be 7 plus 1, which is 8 over 2, which is 4. So the 4th position is 1, 2, 3, 4. 55 on this side. And then for quartile 3, it's going to be 1, 2, 3, 4, 77 on this side. And so I've got to put those 55 and 77 are my, okay, this is my quartile 1, and this is my quartile 3. And so then I'm going to put my lines through the middle 3, box them in, draw my whiskers, and then if I were to look at this and have to explain what I see, I would see that the lowest height of the waves would be 40 inches, the highest would be 80 inches. I would see that there's a wider spread in the first 50% of the data than there is in the second 50% of the data. It's more concentrated over here, especially in the last whisker there, the last 25% of the data. And I would know that the median height of the waves is 67 inches. So that's about it. All right. And 50% is between 55 inches and 77 inches. All right, guys. So if you have any questions about this, ask me in class. Have a great day. See you in school.
Bye.